One of the biggest questions we face as a species today is if we are all alone in this endless cosmos. It is a point of significant debate in the scientific community and brings up tons of excitement in the populace all over the world. This is why it is completely justified that whenever we observe the slightest hint that life exists elsewhere, we are overcome with curiosity and a will to learn more. One of the biggest hints we have received in recent times is mysterious radio bursts from deep space. This phenomenon is not a new one, though. We have received such signals from outer space for decades now, and most of them end up being easily explained by science. NASA's Hubble Space Telescope has been instrumental in helping trace the locations of at least 5 fast radio burst signals. These powerful blasts generate significantly more energy than the sun does in a year in just 1,000th of a second. And now scientists have discovered a host of new radio bursts originating from within the Milky Way and other nearby galaxies. These perplexing phenomena were observed among a nearby population of ancient stars and are one of the biggest astronomical mysteries of today. In today's video, let's talk about what these signals may be and what they mean for us here on Earth. Fast radio bursts are extremely brief bursts of radio waves that were first spotted in 2007 and usually originate billions of light years away. Until recently, scientists believed that the only thing that could cause such phenomena were powered by young, short-lived cosmic objects called magnetars. Magnetars are the most powerful magnets in existence. They are an ultra-powerful and exotic type of neutron star that is surrounded by a magnetic field. Since this field is thought to be at least 1,000 times stronger than a normal neutron star and about 1 trillion times stronger than the Earth's, magnetars were the perfect explanation for the existence of fast radio bursts to date. That is, until recently. A startling discovery was made when fast radio bursts were observed coming from the direction of a neighboring spiral galaxy called M81, about 11.7 million light years away. According to many researchers, finding this burst among a cluster of aging stars in this galaxy is something that simply does not make sense. So far, the scientific community has struggled to untangle this mystery and is moving closer to the conclusion that maybe there are multiple ways fast radio bursts can originate. The first of these new mysterious signals were picked up in January of 2020 by the Canada Hydrogen Intensity Mapping Experiment Telescope. This modern facility has been instrumental in increasing our understanding of these radio bursts since its inception in 2017. Before it, scientists knew of fewer than 30 fast radio bursts, and the telescope has helped boost this number by more than 1,000. This new signal was similar to at least 24 previously known bursts, since it produced multiple detectable blasts of radio waves rather than exploding once and vanishing. These bursts are usually not as bright as compared to those originating from billions of light years away in the distant depths of space. Over the last year, these signals have allowed scientists to better identify their location in the sky. Once that is confirmed, it may become easier for teams to try and attempt to find a source of these bursts. When measured, the data suggested that these fast radio bursts originated from far closer than initially assumed. Astronomers were quick to realize they were hunting for something local, maybe even within the Milky Way itself. As a result, a network of radio telescopes called the European Very Long Baseline Interferometry Network was used to pinpoint the exact location of the perplexing signal. This led to the conclusion that the fast radio burst is associated with a globular cluster in the M81 galactic system, which means that it is around 40 times closer than any previously known extragalactic fast radio burst. This discovery has been very alarming for scientists, as it does not fit into any existing models or understanding of these bursts. This is because globular clusters are among some of the most ancient objects in the observable universe. They are estimated to be billions of years old, sometimes even older than the galaxies they orbit. Since the initial belief was that fast radio bursts can only be caused by magnetars, the theory has since collapsed, as these densely packed globular clusters don't contain any stars which can collapse into neutron stars. Magnetars can be found all over the universe, even in our galaxy, but one has never been observed in a globular cluster to date. It has taken over a decade and a half for us to better understand the mystery of fast radio signals. Initial theories suggested they could originate from sources such as evaporating black holes, colliding dense objects, flaring dead stars, and even alien technologies. Upon further research, it was discovered that the nanoscale structures within these signals, in addition to their millisecond duration and intensity, meant that they must be produced by compact, extremely dense objects. This is what allowed scientists to first consider objects such as black holes and neutron stars as likely candidates for the origin of these bursts. These cosmic objects are the leftovers of massive supernovae, which occur when a star blows itself up at the end of its life. However, later it was observed that most of these bursts originated in regions with extreme magnetic fields, which led scientists to believe that they must be caused by magnetars. Additionally, a magnetar within the Milky Way produced a similar radio burst last year, which further solidified this theory. However, the blast was much weaker compared to the extremely powerful ones coming from across the universe. With these recent discoveries, though, scientists are not sure anymore, and further research is needed to confirm the origins of these mysterious new radio bursts. There is a massive debate on how a population of extremely old and quiet stars can generate blasts of such power, nor can anyone answer how magnetars may exist in a globular cluster. While the likelihood of a magnetar in a globular cluster does seem unlikely, other types of dead stellar objects should be present in abundance. For example, white dwarfs, which are formed when stars turn into red giants and eventually die, and even neutron stars formed by larger supernovae can have a presence in these ancient clusters. One theory suggests that perhaps magnetars can be formed when two neutron stars collide and merge. There is also a possibility of this happening when two white dwarfs collide, or when a white dwarf and one of the objects orbiting it steals so much mass that it turns into a newborn neutron star. However, this has not been observed to happen so far in the universe. For now, astronomers agree that further research is needed to study other ways that may allow for the formation of a magnetar in these clusters and how these objects may be responsible for these fast radio bursts. Additionally, this particular globular cluster also needs to be studied carefully to better understand the origin of these strange signals. This is because not all globular clusters are the same. Some may be denser than others, and different outcomes will likely be observed in different clusters. New studies suggest there may be a possibility to generate blasts that appear similar to fast radio bursts, even in the absence of magnetars. One such way this could happen is if two neutron stars close to each other could generate outbursts that resemble these signals. Additionally, unstable disks of materials caught in a swirl around a black hole may also produce similar jets and flares. While these possibilities are still under consideration, the most likely answer seems to be that fast radio bursts may be formed through multiple pathways, much like gamma-ray bursts. These bursts caused significant confusion for astronomers for decades after being initially discovered by a military satellite, but now we know there are multiple ways these rays are formed, and we may uncover something similar with fast radio bursts. While a definitive answer remains out of reach, astronomers will continue to study these radio bursts from different telescopes in a bid to better understand what causes them and how they can emit such energy across the vastness of space. Another useful application of these bursts is to use them as cosmological probes, which would allow us to further study the distribution of electrons and magnetic fields in the universe in detail. Thank you for staying tuned. We hope you found today's video informative. Please like and subscribe so we can continue providing you with more interesting videos on the mysteries of space. Do you think these radio bursts are caused by the interaction of celestial bodies, or could they be artificially produced by an alien civilization? Please leave your thoughts in the comment section below.